Hey, good morning, CCA Radio. Today we have the pleasure of interviewing Dr. Mario Perez. He's an astrophysicist at NASA, which is one of the main companies that research the space, outer space. Today he's joining us, and we have many questions regarding his project. He had a project on exoplanets, which, and he just mentioned this to us before we began the interview. This is a very current topic in the world of astrophysicists because Nobel Prize was awarded to three people who were working on exoplanets, on research on this. Mario, good morning. How are you today?
Good morning. Thank you very much for inviting me.
All right. Mario, let us in a little bit about the concept of exoplanets. What is exoplanets?
In fact, today, as you said, that was recognized to be one of the achievements worth the Nobel Prize. The story started earlier in the 80s, but this Nobel Prize was awarded for discovery in 1995, which is really 24 years ago, in which it's a very young story, okay, about finding planets outside our solar system, and that the word exo and planets. But not today. There are more than 4,000 of them that have been discovered and confirmed. So we talk about them now more about planets, okay? Exoplanet was the original word to distinguish them from the 8 planets in our solar system, which used to be 9, now 8.
Yeah.
So now the word planets really used for rocky. We're interested in the rocky type of body that go around a star, which is, in this case, is not the sun. It's a different star. And apparently, with the discovery of Kepler, most of the stars do have planets around them, which would be exoplanets. So almost, I think the exception are probably start with no planets around or exoplanet, but most of them, at least all of the ones, have been studied with attention and with a lot of observing time. They have been able to found these planets around them. So since the planetary system are very common in the universe, and have been with the Kepler mission, that was one of the NASA missions that I was program scientist myself here, have been said one of the discoveries that there are more planets than stars in the sky. So essentially, when people look at the sky, they should see not only that number of planets, but maybe many, many more, because star could have 5, 6, 8 planets easily. Planets. Every bright spot in the sky should have another 10 other planets around. So they seem to be common. They seem to be there. And the most interesting one for us are the rocky ones, which are the ones that may or may not support life.
All right. So there is a higher probability of life in the rocky planets, as you just said. How can we know if these planets could be like fosters of life?
Yeah, those are observations that are being done now, because now after discovering indeed there is a planet there, you have to do a characterization. You have to know whether, for example, this planet first is rocky, the density. Mm-hmm. So you need to know about the density. The density tell you whether it's like the Earth or it's more like Jupiter, meaning there are ball of gas. We're not interested in the ball of gas because it's unlikely that life is possible there. But in the rocky planets, certainly we have an interest. But we need to know about the rocky. Secondly, have an atmosphere to support life. The atmosphere could have elements that we know now, like nitrogen, oxygen, methane, and many other chemical compounds that our planet has. So in this case, the characterization process is long, it's tedious, it had to be done with larger telescope. But we just started to study the most intriguing and interesting one, and they will be continue being done in the next decade to precisely go and find life, which is what we're interested in doing.
All right, Dr. Perez. Yesterday, I was reading an article about China growing a cotton plant on the surface of the moon. And there seems to be a tendency for humans to want to colonize or explore, with people, other planets. What are the chances for humans to colonize other planets? Is it feasible?
Oh, I think it is. I think it's possible. Human life is very resilient. It's very adaptable. So humans, in fact, someone from Minnesota was arguing that. I said, I come, an astronomer from Minnesota said, I come from Minnesota. That is a place that 6 months of the year have a very heavy,
it's cold, yeah,
cold and dark, and people seem to live and even thrive. So I presume, yes, colonizing will be challenging, but humans are extremely smart, adaptable, and they will find ways to live in very uh, um, harsh places. So I think colonization of the moon is possible, colonization of Mars, even more possible because Mars seems to have an atmosphere far more similar to the Earth than the moon. The moon is really more, don't have anything on the surface. In fact, doesn't have even an atmosphere. But Mars does have an atmosphere. And it's a thin atmosphere, but not suitable for breathing. But essentially, that can be changed too, because if we were to plan and do some sort of fictitious or experimental or laboratory activities on the moon, who can say that one day we can have air, we can have oxygen. The problem with the moon is too small to attract and retain that kind of gases.
Okay.
Mars may retain them. The Earth is perfect. The Earth has enough gravity that retain the atmosphere, but this other planet may not. So you have to create continuously, air and wind and oxygen on the surface. But who knows? Maybe that's possible in the future. I mean, 100 years from now, I think we cannot say that we cannot do that.
All right. Thank you, Dr. Perez. Dr. Perez, would you please explain a little bit to us about the Cosmic Origins program?
Yeah, the Cosmic Origin program is one of the three, I say here, I show my finger, of the NASA program that we do here in what we call space astrophysics.
Okay.
One of them is Physics of the Cosmos, that had to do with explaining how the universe works. The other one is Cosmic Origin, the one that we're dealing here, which had to do with the origin of the universe, how the universe was formed. Okay. And the third one is about exoplanet, how the search for life. So the Cosmic Origin one, the one that I'm leading, has to do with how the basic understanding how the universe came about, essentially how we can explain the origin of the universe, the origin of galaxies, the origin of stars, the origin of gas and metals created in the universe. Now, this had to do with really an explanation of the Big Bang, how the Big Bang from a very small physical dimensions, so much was created and the universe started an expansion from the beginning until now. So we deal with the beginning of the universe, with the first signals, the first stars, the first any kind of notion or detection we can find at the edge of the universe, because the beginning of the universe has happened at the edge since it's expanding. Mm-hmm. So what is at the edge of the universe is what was at the beginning of the universe. So for us to look at a very high redshift universe is really a way to look back in time. So our effort are to look at the edge of the universe for what is there now, but what it was at the beginning of the universe. So essentially, this duality of space-time is part of what we are working on. So cosmology, right? Uh, Everything had to do with the cosmic dawn, the beginning of the of our uh, our universe, are stages that this program has an interest in studying. And for that reason, we have several missions, including the people probably know Hubble Space Telescope,
Okay.
Spitzer, another mission, Sophia, which is an airplane, another mission that just finished called Herschel. And we will have the largest telescope that NASA built called the James Webb Telescope that will expand our knowledge about the beginning of the universe. And this is the enterprise we're working on. And I say we have missions, we have program, we have archives, we have data, and we have people working on in all of this activity within Cosmic Origins.
It sounds very interesting, Dr. Perez. One final question that may not be part of your field, but a couple of days ago, there was some fear in the world about an asteroid coming very close to the Earth. What's NASA's position regarding these kind of events? Because some are predicted to come in upcoming years.
Yeah, well, NASA has a program mandated by Congress, which is called NEO, NEO Near Earth Orbit Observation, so NEOO. And this program is funded by Congress for us to find everything that is around our solar system that may be a threat to our Earth. So right now, they have done, for example, the inventory of the one that have up to 100 to a few kilometers. But really, what important is to get the one that have about 100 meters. Okay, those are still very damaging if they come in contact with the Earth and the atmosphere of the Earth. The ones that are really large, I said, of the order of kilometers, are known and they're tracked. They're already in inventory. The one on the 100 meters or the meter size are not, because they're smaller and they're harder to find, certainly. But the inventory is being completed, so we do have an interest. NASA invests money on that, and we do it mostly from ground-based telescope that exists throughout this country. Also in Australia, by the way, for the southern hemisphere.
Okay.
But we do have telescope in Hawaii, for example, that do this tracking. It's interesting the time when they do this tracking. It's not at night, because at night these objects are invisible, but they do track this object at the called sunset, or the twilight.
Okay.
So the twilight in the morning or the twilight in the afternoon, meaning when the sun is already under the horizon, but it's still pointing to the sky. Now you can see them. So it's kind of semi-dark.
Yeah.
Essentially, the sun is behind the horizon, but it's pointing to your sky, still illuminated. In fact, there's a time in which you can see a lot of satellite, a lot of artificial and natural satellites coming really fast if you pay attention at that particular time when they're illuminated by the sun, but in kind of direct way by the sun, but you don't get the sun because the sun is behind the horizon. You can observe those objects. So it's interesting that's done during that time too. You need at least 3 points theoretically to know the orbit. So you need 3 observations. With that, you can extend the orbit and know where they're gonna, in what orbit they are. And the orbit determination with at least 3 points. But normally, if you have 5, you have more points and you can do it more easily. No, it's not quite that easy as it sounds, but you need observation of the same object So that's the
Okay.
key, that the same object, three different times, which could happen in few hours, could happen in few nights, depending on how fast or how distant they are. They're going to appear faster if they're closer, and they're going to appear more slower if they are more distant.
All right. Dr. Perez, thank you very much for your time. It's very enlightening to talk to you to understand a little bit more about exoplanets, now called planets, as you said, and the probability of life. And thanks for, basically taking care of us with all this information.
Well, thank you very much. Thanks for inviting me. Hopefully people get excited about this news and don't they get terrified, okay? Don't lose sleep for any of the what I said about the origin of the universe and the end of the universe, and certainly about the potential catastrophic crash of any of this NEO with us. I think things are under control, and expect that technology, investigation, and resources we have here can help us illuminate better our current, present, and the future.
Thank you very much, Dr. Perez.
You're
Appreciate it.
welcome. Thank you very much.
Bye-bye.
Bye.